This video contains footage that I made for a different edition of your book. As is often the case with textbooks, most of the numbers and examples are identical. The only difference is the name of the section. What's up, good mathematicians? We've got section 3.72, the combination of functions. This is our second day in the section. So what I wanted to say is, let's say we had just an experiment where you were finding the boiling point of water, and you did it in degrees, and you measured that the boiling point of water is 212 degrees. Great. If you wanted to translate that into Celsius, we have this function here called the Celsius function, and you just basically put 212 degrees into the Celsius function, the temperature. You'd subtract 32 and multiply it by the fraction, and you'd get 100 degrees Celsius. But then, let's say you had to further translate it from Celsius to Kelvin. Well, what you could do is you could put it into the Kelvin function. You'd take 100 and add it to 273, and then you get 373 Kelvin. Great. The whole transition from 212 to 373 involves putting it into two different functions. You could do the same thing for 50 degrees. Put 50 into the function and subtract 32, and then multiply it by 5/9, and you get 10. And then you'd have to take the output of this function and turn it into the input of this function. 10 goes in here. 10 plus 273 is 283. You have a similar story for the freezing point of water. It goes here into the function. You get out 0. 0 becomes the new input. The new input is 0. And then when you add, you get 273. Wouldn't it be a whole lot easier if your goal is to go from Fahrenheit all the way to Kelvin if you were to come up with another function, just one single function that you could put all this in? Just like it seems like a whole lot of work to go back. What if you could somehow have one function go directly from Fahrenheit to Kelvin? Well, that's what the combination of functions is. We're going to call this the composition of function. You're going to take two functions and put them in, combine them together. And what this is going to read is, if you have the composite function, it's going to be read as f composed in g of x is the same thing as f of g of x. So here, g of x would be the first function. And let's just use a simple function like 2x. You take the input 7, you multiply it by 2 and to get 14. That's the output of g of x. It also becomes the input of f of x. 14 plus 1 is 15. So what you could do, if you wanted to figure out what that function with a combined function would be, this composite function, it would be f composed in g of x. That's really the same thing as f of g of x. Now, what is g of x? Well, we've already said g of x is 2x. So why don't we just replace g of x with 2x? So then we have to figure out what f of 2x is. Well, the f function is just adding 1, so you could take 2x and you're rewriting f, and instead of x, write 2x. That would be 2x plus 1. Without the parentheses, it's just 2x plus 1. Here's the composite function, just simplified together. If you could take 7 and put it all the way through to this output, you would need 2x plus 1. And that's exactly what we do right here. What is f composed of g of 7? That would be 2 times 7 plus 1, which is 15. All done in one function as opposed to thinking about it as two functions. So here it is. You could also just rearrange this and say, what is g composed of f of x? Or you can rewrite it as g of f of x. And what is f of x? It's just the add 1 function. So we really could just say, what is g of x plus 1? Well, the g function is you multiply by 2. So this would be 2 times x plus 1. And simplifying, you get 2x plus 2. So here, let's say we were going to put 7 into the function. What is g composed of f? You just read it across. G composed of f of 7. You get 2 times 7 plus 2. Just knowing what the function is, you could say it's 2 times 7 plus 2, which is 16. So notice that the order matters. If you compose f in g, then you get 15, but if you compose g in f, you get 16. Similarly, the order matters up here when you're finding the actual functions. You do 1 first, it's 2x plus 1, then in the opposite order, it's 2x plus 2. So order matters. What if we wanted to find g composed in g of 1? That would mean running the number 1 through the g function, and then take the output and running it through the g function again, 2 times. Well, if you wanted to do this, then you have 2 options. First option is to do exactly what I said. Take the number 1, and, first you can rewrite it like this. Take the number 1 and put it through the g function, multiplied by 2, and you get 2, and then take 2 as the new input and run it through the g function again, and you get 4. Great. That's the answer. Your second option would be to first figure out what g composed in g of x is. G composed, that would just be g of x, and then you'd get g of 2x. I mean, g of x is just 2x. So taking 2x, the entire function, and running it through the g function, you'd get 4x. So knowing that the entire explicit function of g composed in g of x is 4x, you could just take 1 and multiply. Instead of having to multiply by 2 twice, just know that you have to multiply by 4 one time, and then the output is 4. So overall, the strategies are, for something like this, option 1 would be to take the input and just manually put it in twice. If you don't know what the composite function would be, or you could figure out the composite function and then take the input and run it through once. In general, I think option 1 is easier, but you can do either. Very lastly here, what is f composed in f of x? We want a function here, so you take f composed in f of x, and maybe it's easier to rewrite it as f of x. And then what is f of x? It's x plus 1. So you're just adding 1 right here. X plus 1 we're replacing f of x, the inside f of x, with x plus 1. And then taking all of x plus 1 and putting it through the f function, and we get x plus 1 plus 1. This one is what used to be the inside f of x, and this is what used to be the outside f of x. Anyway, when you simplify this, you get x plus 2, and that's the simplified version of f composed in f of x. So go ahead and get started on the assignment. I'd like you to copy down the question, and then just know that Madrid is the capital of Spain, and that's your audio check, because I've been there. It was a lot of fun. I was only there for like 6 hours, 7 hours on a layover between other countries, but there it is. You tell me about Madrid if you've ever been there, and I'll see you in class.